All right, today we're going to solve radical equations, and in order to do that, we're going to go over some of our exponent properties and talk about rational exponents first. So up here, we're going to recall some of the exponent properties we learned in Algebra 1. We learned if we're multiplying two things with the same base, we keep that base and we add the exponents. So that would be 3 plus 2, which is 5. Same thing here. We keep our base, we add our exponent, so that would be a to the 13. Now, when you are dividing two things with the same base, they have to be the same base, you keep the base and you subtract our exponents. And so here we get a to the 4th, and here we get a to the 6th. Now, when we have a power to a power, we are going to multiply. So we get a to the 6th power and a to the 40th power as we multiply those two exponents. Now, when we have a negative exponent, that's when we do the reciprocal. So this would become 1 over a cubed because any whole number is over 1. So we flip that. Same thing here, that becomes 1 over a to the 8th power. A common mistake is students put a negative on that. You can't just make it negative. It is the reciprocal. All right, the reason why we reviewed those is because we can rewrite radicals as a rational exponent, which means a fraction exponent. And we can rewrite the power with a rational exponent as a radical as well. So here is some examples shown to you on rewriting those, but I want to get down here to the rewrite part. So this is the nth root of x to the a power. So this index part right here for the radical, like when we say the square root, that is a 2 there. The cube root, that would be a 3. So that becomes our denominator. And then this becomes our exponent. To rewrite it as a rational exponent, written like this. So the a was our exponent right here. That becomes, whoops, I wrote exponent instead of numerator. Sorry about that. Numerator. Let's fix that real quick on your notes. The exponent is the numerator, so that's right there. And then the index is the denominator. That goes right there. All right, so let's rewrite some of these here so you can see that. 9 to the 1/2 power is the same thing as the square root of 9. 8 to the 2/3, that would be the cube root of 8 squared. That is my exponent. This is my index. Now we can rewrite this with a parentheses around the cube root, squared with a parentheses like that. We're going to rewrite these radicals now with the rational exponents. So I keep the 16 as my base. And so the exponent there is 1 and the index is 4. So that would be 16 to the 1/4 power. This one here would be 28 to the 1/5 power. So that index is my denominator. If there's no exponent written, that's an exponent of 1. All right, just like with the other exponents up there, the rules are the same for a rational exponent. So we keep our base and we add our exponents. Now, these are fractions, and sometimes students don't like fractions, but you have to revert back to all those fraction rules as well. When we are adding fractions, we get a common denominator. And so that would be 2 over 4 plus 1 over 4. I get a common denominator of 4 here. And so then we add the numerator. So 2 plus 1 is 3, and we keep that denominator of 4. With division, we keep our base and we subtract our exponent. So 2/3 minus 1/6. Again, you have to get a common denominator in order to fix that. And so that is 4 over 6 minus 1 over 6, which then becomes 3 over 6. And we can reduce that to 1/2. This helps us simplify without a calculator much better. And then when we have a power to a power, we keep our base and we multiply our exponents. With fractions, that means you multiply the numerators and multiply the denominators. So that would be 9 over 12. All right, so we said it makes it easier to simplify without a calculator, so that's what we're going to try here. So 4 to the 3 halves would be the square root of 4 cubed. And so this right here is a little bit harder to simplify, but we can do it without a calculator with the rational exponent. What we do is we take our 4 and we break it down with that power to a power property. I keep the 1/2 inside and the 3 outside. Um, if I multiplied 1/2 times 3, I would get the 3 halves. So I have not changed the value of this because when we multiply fractions, we multiply the numerator and the denominator. And this is the same thing as 3 over 1. So 1 times 3 is 3, 2 times 1 is 2. We're back right here. But this can be simplified because we know that to the 1/2 power is the square root. And so the square root of 4 is 2. So we are left with 2 to the 3rd power, which is 8. All right, let's try this one right here. And so we get 27 to the 1/3 power raised to the 2nd power. So we've got power to a power, so that multiplies to be this, but now we can simplify this inside part. Going to the 1/3 power is the cube root, and so the cube root of 27 is 3. And so that is 3 squared, which is 9. That is much easier than trying to simplify that right there. That's the reason why we use these rational exponents. It makes it a lot easier. All right, for this one here, we've got 25 to the 1/2 power raised to the 3rd power. And so 25 to the 1/2 power is the square root of 25, which is 5. And then we have 5 cubed, which is 125. Our next one is the 32 to the 3/5. And so we're going to get 32 to the 1/5 power raised to the negative 3 power. Sorry, that's going to be a negative there. And so we start with the 32 to the 1/5, the 5th root of 32, and these are hard to think through sometimes. So you're going to have to work on that, knowing those perfect squares. But anything that's this big here, you're looking for what multiplied times itself 5 times to give you 32. So it's going to be a pretty small number. And so 2 times 2 times 2 times 2 times 2 would be the answer to that. So that is 2 to the negative 3rd power. Now, when we have a negative exponent, we said we do the reciprocal. So we're going to change that to 1 over 2 cubed, which is 1 over 8. Now, when we get something like this, we're going to have to rewrite that as a rational exponent first so that we can simplify. So this becomes 27 to the 1/3 power because 27 has no exponent here, so that's a 1, and the index is 3. And then we're going to multiply that times x to the 6 over 3 power. So for this one, 27 to the 1/3, we're looking for the cube root of 27. What did we multiply times itself 3 times to give me 27? Well, that would be 3. And then we can reduce this fraction so we get x squared. So this was not as easy to simplify, but it can be done without a calculator. All right, for solving now the radical equations, we are going to isolate the radical. That's our goal, is to isolate that radical. If there's 2 of them, that means we need to put 1 on each side of the equal sign. We are going to have to check for extraneous solutions here. That means that you end up with a solution that looks like it's a solution as you're solving, but then you plug it back in and it does not work. So let's start with this first one. We have isolated the square root because it is by itself on this side of the equal sign. Now to remove a square root, we square. So we're going to square both sides here. The square root and the square cancel, so we get 4 plus 7x is equal to 81. Now our goal is to solve for this x, so we would subtract the 4, and then we're going to divide by 7. And so we get x equals 11. And so when you're checking your work or checking for extraneous solutions, you are plugging this back into your equation here for the x. And so this would be 4 plus 7 times 11 is equal to 9. And so 4 plus 77 is 81. So the square root of 81 is 9. That is true, so we can move on. All right, this is the same if we have a rational exponent. Remember, a rational exponent is the same as a radical. So we want to get that by itself first. So here it is by itself. Now this one, when we raise it to a power, we're going to want a power that's going to cancel this out. So I'm going to raise it to the 3/2 power because then the 3 is in the numerator and denominator and cancel, and the 2 is in the numerator and denominator, so it cancels. Now, whatever we do to one side, we always have to do to the other. So we're going to raise that 4 to the 3/2 power as well. And so this cancels and it frees my x plus 5. On this side, we have 4 to the 3/2 power. We just practiced simplifying these without a calculator, so you can do this without a calculator. We do the 4 to the 1/2 and then raise it to the 3rd power. So the square root of 4 is basically what we're doing here, and the square root of 4 is 2. Raised to the 3rd power is 8. And then our next step is to subtract this 5. X is equal to 3. We plug that back in here and it works, so we can move on to our next one. All right, so we are going to start with this one. It has a square root on this side. It is isolated since it's the only thing on that side of the equal sign. So now we're ready to square both sides. When I do that, I end up with x squared on this side. The square root and the square cancel out, so I get 6x plus 16. Now we're going to make this equal to 0. That's always your first step when you have a quadratic. I have an x squared and an x. So anytime you have that, you're going to want to set it equal to 0 in order to solve. And last unit in the quadratics unit, we learned you can solve a quadratic by factoring, by graphing, or the quadratic formula. This is one that's easy to factor, so that's what we're going to do. X times x gives me this x squared. Then we're looking for what multiplies to be negative 16 and adds to be negative 6. And so that is negative 8 and positive 2. And so my two solutions would be x equals 8 and x equals negative 2. This is a really important place to check for those extraneous solutions because those are both solutions for the quadratic, but we're not sure if they're solutions for the radical. So this is where we really need to check our work. So I plug in 8 there. And so here we get 8 equals the square root of 6 times 8 plus 16, which is the square root of 64, which is 8. And so that works. Now I plug in my negative 2, and I don't even have to go very far to check this. Because right here, I can already see this is not a solution. We know that coming out of the square root, it is impossible to get a negative. You cannot get a negative out of the square root, so this does not work. This is an extraneous solution. It was a solution to the quadratic, but not to the radical. So we want to make sure we cross that solution out, and the only solution given is 8, because negative 2 is not a real solution. All right, for this next one, we have the cube root of this problem is equal to negative 4. This does work because in a cube root, that means that it multiplied its times itself 3 times, and a negative times a negative times a negative is a negative, so this is okay. This one was because it multiplies times itself 2 times, and a negative times a negative is a positive. That's why this doesn't work. So we're going to go ahead and cube both sides. And so the cube root and the cube cancel out, and we're left with 6x minus 10 is equal to negative 64. Negative 4 to the 3rd power is negative 4 times negative 4 times negative 4. Our goal is to get the x by itself, so I'm going to add that 10 to get it to the other side. And then we're going to divide by 6, and we get x is equal to negative 9. All right, our next one here, we're raising it to the 1/2 power. And so in order to get that to cancel, I need to square both sides. When I square both sides, this cancels here. And so we have freed the x squared minus 12. On the other side here, we have x minus 2 squared. Remember that's x minus 2 times x minus 2. So it is not x squared minus plus 4, sorry. It is x minus 2 times x minus 2. So you need to FOIL that. X times x is x squared. We get a negative 2x and a negative 2x, which gives us a negative 4x. And then negative 2 times negative 2 gives us a positive 4. Again, anytime that we have an x squared and an x, we want to get this set equal to 0. So that's going to be our next step. When we subtract this x squared to get it to the other side, they cancel on both sides. So actually, there goes the x squared. And we're left with that there. Now we're going to subtract this 4 to get it to the other side, and so we get negative 16 is equal to negative 4x. We divide by negative 4, and x is positive 4. All right, we've got another one like that one here, and so I'm going to go ahead and square both sides to get rid of my square root. I'm going to FOIL x minus 1 squared, so that's going to be x squared minus 2x plus 1. And then my x squared plus 1 is freed. When I subtract the x squared to the other side, they're going to cancel again, so I'm left with negative 2x plus 1 is equal to 1. I subtract the 1 and I get negative 2x is equal to 0. We divide by negative 2 and we get x is equal to 0. Now, when I plug in 0 right here, that gives me a negative 1. And again, we can't get a negative out of that square root. So this is what a no solution looks like. That did not work. We do not want to put that as our answer. On this next one, we're going to want to isolate our radical first. That should be the first step. So I'm going to subtract that 2 to get it to the other side, and I get 2x minus 6 is equal to 3. You can never get rid of that square root until it is by itself. If we tried to square all of this, we would have to FOIL and make kind of a mess there. So you want to get that by itself, and then you want to square. The square root and the square cancel, so we get 2x minus 6 is equal to 9. We add the 6, and we get 2x is equal to 15. And then we divide by 2. X is equal to 15 over 2. And you should always be plugging these back in, making sure they work. So I've checked them, those work. All right, so now we're going to raise this to the negative 2 power. This was a negative 1/2, so if I raise it to the negative 2, that's going to cancel, and a negative times a negative turns it into a positive. So my x is freed. Now to fix this negative here, not fix it, but work that negative, we do the reciprocal, so the 9 is going to come up to the top. You do the reciprocal to get rid of the negative exponent. And then 9 squared is 81. All right, now we're going to look at some that have 2 radicals. So if it has 2 radicals, you're going to want 1 on each side like this. And then we're going to square both sides. Now when we square both sides, it is going to cancel both of the sides, or the square roots. So we free the 5x minus 3. It is equal to x plus 13. I subtract my x. I add my 3 and divide by 4. X is equal to 4. Again, we're checking all of these. I've already gone ahead and checked them, but make sure you check your work always to verify that it is not an extraneous solution. Or a no solution like this. We had a solution, but when we plugged it in, we saw it didn't work. So you want to make sure you do that. All right, for this next one here, we're going to square both sides to get rid of my radicals. When we do that, my right side here is freed, so I have x equals 25, but I do want to talk about this side. Very often students will go ahead and cross this out with this 2, but that does not work. You have a 2 right here as well, so you've got to square both of them. So 2 squared is 4, and then the square root and the square part are going to cancel, freeing my x plus 7. I distribute. I subtract my x to get it to the other side. I subtract my 28, and my x is negative 1. I plug it back in, verify that it works. All right, we're down to our last 2 here. I'm going to go ahead and raise this one to a negative 2/3 power. And I'm going to do that to both. The 2's cancel and the 3's cancel here, and a negative times a negative is a positive. So my x minus 20 is released. For this one here, I'm going to get rid of the negative first. I feel like that always helps out. So I'm going to do the reciprocal of this. So I get 64 to the 2/3 power. Now we learned that to simplify this, we leave the denominator part on the inside and the exponent on the outside. So I need to take the cube root of 64. I'm looking for what multiplied times itself 3 times to give me 64. That is 4. And now I can square it. That is 16. I add the 20, and I get x is equal to 36. All right, our last one. Just like with the radicals, I got to get this by itself, so I'm going to add that 5 to get it to the other side. Now we raise them to the 3/4 power. That cancels, and we free our x plus 2. Right here, we're going to do 16 to the 1/4 raised to the 3rd power. So we're looking for what multiplies times itself 4 times to give me 16. That would be 2. 2 times 2 times 2 times 2 is 16. I cube my 2, and I subtract my 2. Lots of 2's there. X is equal to 6, and so that is solving radicals.